Hello everyone. Today we will study about the combination of cells. So first we'll discuss the series combination of cells. Series combination means the two cells are arranged like this with the positive terminal of one to the negative terminal of the other. So in such cases we have to find out what will be the equivalent EMF and the equivalent internal resistance for this combination. So if this R1 is the internal resistance of the first cell, R2 is the internal resistance of the second cell, E1 is the EMF of the first cell, E2 is the EMF of the second cell. Then if we have to find out the net equivalent EMF between points A and B, the formula for that obviously will be E equivalent minus I into R equivalent is equal to V equivalent, right? So let's write the expression separately for the first cell and the second cell. If we want to find this, these are in series, so we can say that V equivalent is equal to V across AC plus V across CB. Why? Because if V1 is the VAC is the V across AC and VCB is the voltage across CB, then obviously V equivalent across AB will be equal to VAC plus VCB, right? So for first cell, that means for VAC, we are writing for first cell V is equal to E minus IR1. Why so? Because these two cells are in series and the same current is passing through both the cells. So if we write for the second cell, V across CB is equal to E2 minus IR2. Now, if I take this as equation 1, this as equation 2, I can add these two equations to find the V equivalent, that is VAC plus VCB is equal to E1 minus IR1 plus E2 minus IR2, right? So this can be written as E1 plus E2. I'm writing one extra step to make the things clear. So this can be written as, I've taken I common from these two terms. So VAC plus VCB, if we mark this as our equation 3, so this can be written as V equivalent. And if I mark this as 4, I can put its value as E equivalent minus I R equivalent. Now you can compare the left hand side and right hand side. E equivalent is equal to E1 plus E2 and R equivalent is equal to, here you can mention here that this is from equation 4 and this is from equation 3. So this is about the series combination. Now we'll take the case of the parallel combination, and there also we'll find what is the equivalent EMF and the equivalent internal resistance of the parallel combination of the cells. Now for the parallel combination of cells, I'll draw the diagram. So let's take two cells. The first cell having EMF E1 and the internal resistance R1. The second cell E2 having internal resistance R2. These are connected in parallel. That means the positive of cell 1 is connected to the positive of the cell 2, right? So if I take this as I1 and this current through the second cell as I2, so the total current here will be I. We know that the potential drop across these will be same. Here across this will also be same because potential drop is same in the parallel case. So V is same for cell 1 and cell 2. We'll write the expression. We know the formula. V is equal to E minus I R. If we are writing for the first cell, I'll write V will be same E1 minus I1 R1. From here, I can find the value of I1. So this I have written for cell 1. So for cell 2, but for I'll first find out this I1. So I1, R1 I have shifted on left side and V I have shifted on the right side. So this gives me I1 is equal to E1 minus V upon R1. Similarly for cell 2, V is equal to E2 minus I2 R2. So therefore, same way, this can be written as I2 is equal to E2 minus V upon R1. This I can mark as first equation. This I can mark as second equation. And we know that the total current, this is equal to I1 plus I2. I can solve it. So this will be E1 minus V upon R1 plus E2 minus V upon R2. This I have written from 1 and 2. From 1 and 2. Now this is the total current. So let's rearrange it. I can take this here. This can be written as E1 upon R1 minus V upon R1 plus E2 upon R2 minus V upon R2. Solving further, E1 upon R1 plus E2 upon R2. I have clubbed these two expressions together and these two I am taking together. So this is, in next step I can take V common. So E1 upon R1 plus E2 upon R2 minus V I can take common. So here it will be, right? So since our standard equation is in the form of V is equal to E minus IR, so I'll keep this in the same standard form. So I'll shift this on left side and this on the right side. So this is minus sign, so on shifting it will become positive. So V 1 upon R1 plus 1 upon R2 is equal to E1 by R1, E2 by R2 minus 1. Yes, minus 1 minus I. So I've shifted this I on the right side. Now if I divide the whole equation by this quantity, so if I divide the whole equation by 1 by R1 plus 1 by R2. So on left side what will remain, beta? So this will remain V only, and here E1 by R1 plus E2 by R2 upon 1 by R1 plus 1 by R2 plus, no, this is minus I upon 1 upon R1 plus 1 upon R2. Now only calculation is required here. So this V can be written as E minus IR. So I can write E equivalent minus I into R equivalent is equal to, let's solve this. So let's solve the numerator first. E1 R2 plus E2 R1 upon R1 R2. This is the numerator. This part I have taken R1 R2 LCM. Now upon this will be R2 plus R1 upon R1 R2. I have solved the denominator here. Minus I upon, again I am solving the denominator of this term. So this will be R2 plus R1 upon R1 R2. Only one step is left now. So that step I will write after rubbing the left side of the board. Hope it is clear up to this step. Only 1-2 steps are left here. So I'm just rubbing the diagram and I'm writing the last step here. So E equivalent minus IR equivalent is equal to, we can cancel a term from here. Look at this. This and this term will be cancelled. So what will remain? E1 R2 plus E2 R1 upon R1 plus R2 minus I. This can be taken to numerator. So I can write R1 R2 upon R1 plus R2. Right? I hope it is clear up to this step. Right? Now here compare both sides of the equation. So if we compare, look at this. E equivalent is this much. So you can mark over here for simplicity that this term is equal to this term and this term is equal to this term. So I can mention it. Therefore, E equivalent is equal to E1 R2 plus E2 R1 upon R1 plus R2, and R equivalent is equal to R1 R2 upon R1 plus R2. So this is our result for the parallel combination of the cells. I hope this is clear to all of you. That's all for now. Thank you.